Okay, here's the final video before I do my test on this modified rowing hull. The only thing left to do is add oar pins. I checked the geometry. I just checked the sweep distance just to make sure that the oar pins are going to be in the exact middle between my forward-most hand position and my rearward-most hand position. So that blue tape in the middle is the middle, and I'm assuming that you want equal angles on either side of the stroke, and so that's how I determined that. Now it's just a matter of how high to put the pins. Currently the deck of this arm is 3 inches higher than the top of the seat, but I believe the standard is closer to 5 inches. So I have to elevate the pins a couple inches, or the oars need to be a couple inches higher than that deck right there. And to remove weight, because since I'm adding weight, I punched a bunch of holes and it's still very strong. So the next video should be on the water. Honestly, I think there's about a 50% chance of this actually working in this configuration. It's quite possible that I need more flotation, like a third hull in the middle, and I might have to make it lighter. One viewer asked, why is my boat so heavy? The reason it's so heavy is because this is these floats are double skinned. They're skinned on the top and the bottom. If this was like an open canoe, I could completely remove the tops. So if this doesn't work and it ends up being too heavy, what I can do is just integrate the rowing frame and the hull into one continuous thing instead of having 3 different parts, and then that would eliminate the need to deck the top of these floats, because water would not then the sidewalls would be taller and I wouldn't have to worry about water washing on top of these things. So that would make it lighter. Okay, so one more interesting observation. So my dynamic weight is centered on my belly button. It's actually a couple inches in front of my belly button when I'm forward and about at my belly button when I'm back. So the forward position is here, the backwards position is here, the middle is here. As far as the amount of time that I'll be spending here and here relative to the middle, I think it might be closer to here, because I think it takes longer to get back than it does to get forward. So I think you're pushing off here really quick, so you're accelerating, and when you get here you don't have a lot of strength to turn around, because you're using a different muscle group. So in reality I'll be spending more of my weight will be probably here. Anyway, the center of buoyancy is here. However, as I get going faster, the center of buoyancy will move approximately around 12 inches forward. So the reason it moves forward on this one is because of the design of the hulls. They're not like a regular speedboat hull. I'm not really sure what that means for the pitch. Boats have all kinds of pitch issues, and the pitch actually goes up and then it goes down over the hump speed. But I'm in the right ballpark. And my only concern is that water washes over the top of the rear float before I get up to planing speeds, and the weight on top of the float would make it heavier. Anyway, that's my only concern. So I thought about adding like a splash guard to the leading edge of the back float. that's something I could always do. Here's all my boats that I built in the last couple years. My punt, my wingman, and the floats for this experimental rowboat. Yeah, so I could add basically, yeah, some kind of wave guard here, just to keep water from washing over it until I get up to speed.